Morning. Before studying the Revit, we want to study what is BIM. For that, we are making the introduction to BIM process. Okay, BIM is not a software. Everybody have a doubt that BIM is a software. BIM is not a software. It is a process. Okay, the process of combining lot of softwares will be as BIM. It's together is the process is the BIM. BIM means the building information modeling. Okay. The full form of BIM is building information and modeling. The BIM is used in every sectors. Nowadays, the engineering students, architectural students, or in every streams, the BIM is used. BIM is mandatory in so many countries. Nowadays, BIM is more mandatory because the cost of the building will be decreased when implementing the BIM. It has a greater visibility and a better decision making. If we needed to change its fault structures can be made at the time of creation of the model that can be used in the BIM sector. Okay. Or once we use the BIM software, so that is if we using the Revit software, we can make the scheduling and all like that. We can make the scheduling and we can make the material takeoff. All can be done at the scheduling process. All will be on the Revit software. So the BIM is mandatory in so many countries. This is the reason why the BIM is mandatory. The main software behind the BIM is Revit. Okay. And BIM is on AEC projects, that is architectural engineering construction projects. BIM is used. And what is BIM? Building information modeling as a process of designing, construction or operating a building or infrastructure assets using electronic object oriented information. It is the definition for the BIM. Okay, that is a process, not a single technology or solution or software. It's the collaboration of so many softwares, that is it's AutoCAD, Revit, Navisworks, Lumion, 3ds Max, or like that softwares. All combining the process is called BIM. We can use a SketchUp as a pre stage of BIM. Now further we can use Revit software. From the Revit software we can make the documentation of the wall drawing, documentation of the wall building. It is that is the reason why Revit is the key software of BIM. And these are the benefits of while using the BIM in construction. Maximize the efficiency. The efficiency can be calculated and reduce cost and wastages. We can get the accurate amount of material, and the cost can be get after implementing the BIM. And improved cost estimations can be estimate the cost also. But inside the info projects we can change the structures as before the construction, and we can make a better solution. Further that we can coming to the project implementation. Okay, and communication and collaboration. The collaboration and communication will be more easier when inventing the BIM. And the risk factor is very small because we will know the full details of the risk when the project is implemented. Before that we can check out the risk and can be reduced that. That is the benefits of the BIM. And better end results. End results can be predicted before the construction also. So the BIM is very benefit in the field of construction. Okay, and the BIM base is LOD. What is LOD? That is level of development. The BIM has LOD 100 up to 400. That is 100 is only the volume. What is the volume? What is the shape, or like that? And 200 enough detail to recognize the components. Firstly, we have only the volume. What is the volume of the project? And coming to the LOD 200, we can get the shape. And coming to the LOD 300, real look, but it's still simplified. Just a simple look can be given for a project. That is, if we taken a case of a house, a simple house, we can get only the volume, only the area in LOD 100. Coming to the LOD 200, we can get a sketch, up to a sketch of the house. And coming to the 300, LOD 300, we can get the shape. Actually, the shape of the, is it a sloped roof or plain roof, like that. Coming to the LOD 350, real look but simplified. It will get a accurate shape if we have a door and door size or like that. Coming to LOD 400, we can get the whole detail of the house. We can get the house shape, slope, have door shape and the door handle shape and door handle details and dimensions. It is the basic level of LODs. Okay, these are the portion we can discuss about the BIM. Further will be discussed on the class. Now we are discussing about the Revit structure syllabus. So here is the Revit structure syllabus. And the first portion is the introduction portion. The introduction to BIM is the first session we want to study. What is BIM? We want to study what is the BIM and what is its use, or like that. And the second session is introduction to Revit. And the Revit has three divisions, that is Revit structure, architecture, MEP. Why we want to study the Revit structure? What is the importance of Revit structure? All will be discussing on this introduction portion. And the second portion is the starting a project. How to start a template, how to open a template, how to know about GUI. All will be discussing on this second session. And the second session will be having the further settings, that is unit settings and snap settings will be all covered in this starting a project section. Okay, and the levels and grids can be made at this session, and its family creation will be further discussed on this second session. Okay, coming to the third session, that is the dimensions portions. We can make temporary dimensions also. Before that, we can make a permanent dimension, or we can convert the temporary dimension to permanent dimensions and make an equality constraints. All will be coming under this dimension portions. The dimension portions will cover about the align dimension, linear dimensions, arc length. All will be covered at this dimensions portions. And the fourth session is the linking and importing. As we know, the Revit has so many importing options, import files, that is link Revit, that is link IFC and link CAD, and also the importing options, that is import CAD, import Revit. Okay, this will be discussed about this linking and importing. What is the difference between the linking and importing? All will be covered at this session. And the next session is elements. This is the most important session in the Revit structure. The modeling will be coming under this session, that is placing and modeling walls, placing and modeling foundation, placing and modeling floors, placing and modeling beams. This will be covered at this session, that is elements. This is the important session. After that, we want to reinforce the models. That will be coming under the session, that is the reinforcement in columns, beams, and slabs. The reinforcement will be further discussed on this session. It is the another most important session also. Okay, after modeling, if we needed a family, a default before the default family, we want to make a new family. The family creation will be here. Okay, so the family creation of columns, family creation of beam will be discussed at this session. Okay, after modeling, of the whole process of modeling, we want to schedule it and can be present in a sheet. The sheet setting and the sheet presentation, its calculations, its scheduling, all will be coming under this session, that is scheduling and documentation. After that, we want to print the sheets. Printing the sheets, that printing option, plotting options will be discussed at this last session. These are the full description about the Revit structure syllabus. These are the portions we are covering at this Revit structure. This is the Revit software interface. Okay, now I am opening a Revit structure template. For clicking new and browse, here will be the templates from India, that is structural analysis default metric. It is the template we want to choose from the templates to model a structural file. Okay, for that I am opening. This is the template that opened by Revit structure, that is default metric template. Okay, here you can see the project browser, that is structural plans, that is level 1, level 2 analytical ones. Okay, so I am drawing. I want to reinforce a beam. For that I want to make a grid. So I am making a grid here and here also. Okay, like this. I want a beam that connects this grid. For that I am coming to the structural template or structural tab and clicking the beam. Here is the beam, that is steel beam. So I need a concrete beam. For that I am loading from the libraries, that is structural framing. For structural framing and concrete, and opening the concrete rectangular beam. Okay, override the existing version and its parameter. If we needed to change the length and breadth, so here can be changes. Oh, that is breadth and height can be changed here. You can customize a new length and breadth and height by duplicating this. Now I am choosing this 300 into 600 mm beam. Okay, for that I am clicking OK. I just want to draw it. It is in the level 2, making this beam. We can 3D, we can have this beam. It is not reinforced. We want to reinforce it from going to the level 1, level 2. I needed a section to make a rebar. For that I am making the section here. So here is the section. We can go to the section by double clicking the section head, or came from the project browser. Here will be the sections. You can click from the section 1. So here is the section. Okay, firstly we want to cover the section. We want to cover the we cannot cover the beam. So here is the cover, that is in the structural tab. Here is the reinforcement panel. Here is the cover. If we needed to set the cover setting here. Okay, rebar cover settings. So here is the slabs, walls, joints, shells, and exterior 10 mm, 16 mm, exterior 90 mm, 57 mm. We can choose anything we want. Okay, or we can add another one by adding here rebar cover 40 mm like this. Okay, can choose anything. So I am clicking here cover. We get two options, that is pick elements and pick faces. If we needed one cover, we can use this pick elements. If we needed 4 faces different covers, we can pick the pick covers and pick different covers in it. Oh, now I want a pick element, just cover it. Okay, so the cover is applied here. Once we make the cover, we want to rebar it. For that we want to come to the reinforcement panel. Here is the rebar option. I am clicking the rebar. We want to load the rebar shapes. So the rebar shapes is loaded here. We can know the rebar shape browser is opened here. Just first want to make the stirrup. For that, here is the rebar shape MT1. I am clicking the rebar shape MT1, and we want to make adjustments. If we needed the dia here, that is 10 mm dia, 13 mm dia, 16 mm dia, 19 mm dia, like this. Okay, if we needed a suppose we needed a 12 mm dia bar, so there is no 12 mm dia bar set here. You want to edit type, go to edit type and make a new one, that is duplicate. I am giving the name 12 mm. 12 mm. Clicking OK here, and came to edit the bar diameter to 12. Okay, I am changing it to 12 mm. And here will be the standard bend diameter, that is the bend diameter, and it's a hook diameter also. These two are standard. And the stirrup tie bend diameter also. Here is the stirrup tie bend diameter, that is 80 mm. We can change it if we needed. Okay. Now I am going to I'm not going to change anything. That is, I am needed a 12 mm dia bars. Okay, clicking OK. So here the rebar is just here. It is 12 mm. We can change the hook's position by clicking like this. Okay. Once we edit the rebar dia, we want to place it. So here is the current work plane. That placement plane is the current work plane. Here is the current work plane. Or near cover reference. If we know that is cover is applied here. So near cover reference is same like that. Okay, here is the near cover reference. And here will be the far cover reference. That is the back side of the cover. Okay. Just I want to current work plane, and the placement mode should be parallel to work plane like this. If we are choosing the parallel to work plane, it will be the stirrup will be given like this and this. If we are choosing the perpendicular to cover like this. So we want to choose parallel to work plane. The reason that I choose parallel to work plane is I chosen the placement plane as current work plane. That is the reason how I chosen the parallel to work plane. And from the rebar set, there is layout have so many options. That is single. If we needed one stirrup, we can use the single. If we needed a 3 or 4 number of stirrups, we can choose pixel number. If we needed a maximum spacing as the spacing distance, so we can choose maximum spacing. And if we can type 120 mm, 130 mm, 100 mm like that, the quantity will be automatically updated by minimizing or maximizing the spacing. And the number with the spacing, we can control the quantity and the spacing too. Okay. And the minimum clear spacing can be changes, the quantity also changes. Okay. So I'm clicking the option of maximum spacing, and the spacing is 100 mm, or we can change this to 120 mm. Okay, clicking 120 mm, I am placing the rebar here. So the rebar is set. If you needed to change its rebar position, we can choose like this. It is the approximately position. If we needed any change, we can change it. Okay, otherwise we can just leave it like this. Okay. After placing the rebar, we can give the editing hook at start, hook at end like this. That is stirrup. So we didn't want to change the hook at start and hook at ends. After giving the stirrups, I want to make a rebar. I want two set of rebar here and here. So I'm going to rebar. I just want to pick the shape. That is M00. And I want a 2 set. So I'm from the rebar set, I'm clicking pixel number, that is 2. So I'm picking placement method as parallel to work plane. So we can do like this. Clicking here. So I just picked it, but I didn't want a 12 mm dia bar for here. I want to make it as 10 mm. So clicking here, I want to change it to 10 mm. And here also I want to change it to 10 mm. And we can know the rebar here. So I want a hook bend diameter, hook bend here. Just want to bend like this here and here. So I'm clicking the rebar. I just want to change hook at start to 90 degree and hook at end to standard 90 degree.